Good evening. Tonight we're going to be working on integer exponents. The I cans you are going to focus on. I can apply the exponent rules and I can rewrite negative exponents as positive exponents. So first, looking at this, when I have linear functions, they grow in equal intervals. Now we're going to be looking at what's going on with exponential functions. So first thing we're going to fill out is this table right here. So I can see 3 to the first is 3, 3 to the second is 9, 3 to the 7, or 3 to the third is 27, 3 to the 0 is 1, because anything to the 0 power is 1. 3 to the negative 1 is 1/3, 3 to the negative 2 is 1/9, and 1/27. You want to look through and seeing the pattern here is now multiplied each step by 3. The integer exponent definition. So there's 3 basic things we're going to look at. If I have b to the n, that means that I have that many b's. For example, b squared would be b times b. Okay, the next one's the big one right here. Anything to the 0 power is 1. And then over here, the negative exponent brings it to the denominator, okay? So we're going to look first here at example 2. We have the function f of x equals 20 times 2 to the x. Evaluate each of the following without using your calculator. Now, we're not saying the calculator is going away. We just want to look at where this is coming from. So first, f of 2 would be 20 times 2 to the 2. Now let's just have this quick conversation right now. There's this tendency to say, oh, look, 20 times 2, there's 40. Don't do that. Don't do that. Order of operations first says deal with your exponents, PE, right, your exponent, then multiply. The other way to look at it, this 20, original pony. This here with the 2, that's a unicorn. They are different. They are not the same. So you want to keep them separate. So first, 2 squared would be 4. Then I'd multiply through by 20, and I'd get the 80. You know as well that you could go into the calculator and store these values. So that's how you're going to check these. Now the next one, f of 0, 20 times 2 to the 0. Remembering our rule right here that anything to the 0 power is 1. So then I have 1 times 20 is 20. And then lastly, we have the negative exponent. So f of negative 2 equals 20 times 2 to the negative 2. Dealing with that first, 2 squared is 4, and then the negative brings it downstairs, so that's 1/4. And then 20 times 1/4 is 5. So now we have a little bit of a thinking question, and notice the other excitement here. Explain your answer. Those 3 little words are just going to cause so much stress in your day. So when x is increased by 3, by what factor does y increase? So awesome. What does that mean? Let's get ourselves some more space here. And I'm going to plug in that I'm going to increase x by 3. So that would be f of x plus 3. So 20 times 2 to the x plus 3. And now, as we're thinking about it, if we looked at something at a similar level, like let's just say x squared times x squared, we know that that would be x to the 4th because I add the exponents when I'm multiplying the bases. So I could write it like that. So using that logic here, I'm going to see that I have the plus right there. I'm going to pull it apart and say, okay, that's 2 to the x times 2 to the 3rd. And the 20 is just floating along for the ride. So now I can see the 20s would be consistent. The 2 to the x would be the same. And then 2 cubed would be 8. So it's going to increase the y's by multiplying of 8. And you're going to explain that by saying that I used the properties of multiplying the bases. I add the exponents, and I was able to use that property to expand out the exponent of x plus 3. So we're going to use that property now again. Here we can see at the bottom, at number A here in example 3, we have 2 cubed times 2 to the 4th. So that would be 2 to the 3 plus 4 is 2 to the 7th. Sorry, guys. So you're going to try the next one right here. And then I'm going to look here at the variables just to bring it home one more time that if I am multiplying the bases, I add the exponents. Okay? So in number 4, using the exponent laws found in 3, you're going to now look at that, how I can make a single exponent. Same rules apply, that when I go through, that if I'm multiplying the bases, I add the exponent. So writing that as a single would become 3 plus negative 1, or 2 squared. First, we want to rewrite them separately. So 2 cubed is 8, and 2 to the negative 1 would be 1/2. And then simplifying that, I'm going to end up with 4. Okay? Then going through, I can see 2 squared would be 4, and 8 times 1/2 would be 4. So the property is working for us. Okay, now we're going to look at the next important property, power to a power, all right? When we're looking at this, power to a power, we're going to multiply. So here we go. In the first one, I have a base of 3 squared raised to the 3rd power. For each of these, we want to write an exponential form. So we would first say that this will be 3 to the 6th. Another way you could have looked at that is say, okay, it's 3 squared 3 times, and then you can see I'm multiplying the bases again, therefore add the exponents. I'd like you to try B, and I'm going to come over here and do C, doing the multiply. If you want to write it out first, go right ahead, okay? That you would write out 3 to the 4th twice, and then add those exponents, or use the next property and multiply them. Okay, example 6. Consider that you have 3 to the negative 2 to the 4th. We're going to break that down. So we want to show that it's equivalent to 3 to the negative 8th. If I rewrite 3 to the negative 2 in fractional form, first that would be 3 to the 2 in the denominator. That is equivalent to 1/9. You could then show, raising that 1/9 to the 4th power, that you could write that out 4 times and multiply through. So I'm going to let you go through, multiply those, and show that it's the same as 3 to the 8th. All right, so now we're looking here and we're just starting to think about what is going on. Determine the integer value of n that satisfies the equation. So now you're almost having to think backwards. So basically, 4 to what power is 16? So you might want to just start thinking, okay, 4 times 4, 4 times 4 times 4 times 4. And you know that if you end up with 4 times 4, you are going to get 16. So this will be n to the 2nd, or n equals 2. Now here, in this one, this is the one I'm leaving for you. I am going to leave you a hint that the value of n that we get is going to have to be a negative, remember, because we were taking this whole number 3 and it's becoming a fraction. So you know your answer is going to be something negative, and you just work through the process. And the last one here, big stars. So how many times can we get this? Anything to the 0 power is 1. So that finishes our first video on the integer exponents. You're now going to watch one on rational exponents.